Here, this is the 2014 AIME 2 problem 10, and let's have a view of this problem. Let z be a complex number with modulus of z is equal to 2014. Let P be the polygon in the complex plane whose vertices are z and every w such that 1 over z plus w is equal to 1 over z plus 1 over w. Then the area P can be written in this form, and we want to find the remainder when n is divided by 1000. Okay, so first let me list what I know. I know that the modulus of z is equal to 2014. This means that z will be a complex number lying in a circle with radius of 2014. And then now let's work on the condition that they're giving us. 1 over z plus w is equal to 1 over z plus 1 over w. We can easily just write this as 1 over z plus w is equal to w plus z over wz. And then from this we have w plus z squared is equal to wz, and then from this we have that w squared plus w plus wz plus z squared is equal to 0. So now what do we want to do? And the vertices are z and every w such that this is the case. So we want to find the w in terms of z, right? So we solve this as a quadratic in terms of w. So w is equal to negative z plus or minus the square root, and this is z squared minus 4z squared over 2. Okay, I'm liking this. This is negative 3z squared. This can be written as negative root 3 times negative square root of 3 times square root of z squared. This can be written as root 3iz. So this can be written as negative z plus or minus root 3iz over 2. Okay, this can be written as negative 1/2 the z plus or minus root 3 over 2 zi, perfect, and then factoring we get z times negative 1/2 plus or minus root 3 over 2i. Now this is great. So now we can write w as z times negative 1/2 plus root 3 over 2i. Let's actually convert that into exponential form. That will be e to the 2 pi over 3. So z times e to the 2 pi I over 3. And then w can also be, when this is negative 1/2 minus root 3 over 2i, that'll be an argument of 240, or e to the 4 pi I over 3. Okay, great. So now we have enough to get a geometric interpretation of this. So this is basically just, in the Cartesian diagram, a circle of radius 2014, and then wherever we place z, we know that one of the wz will be a 2 pi I over 3 rotation, and then a 4 pi I over 3 rotations, and then so this polygon will be like a triangle, and we want to find the area of this triangle. Great. Like this, right? And we want to find the area of this triangle. Now, how can we proceed? Actually, if you'll notice, I conveniently place z as 2014, and that's maybe another way of going about this problem, right? We can actually face solve it, and without loss of generality, assume that z is equal to 2014. But in this case, this is just z. This is just z times e to the 2 pi I over 3. And this is z times e to the 4 pi I over 3. And then now, you can actually, if you're familiar with complex rotations, you can actually easily note that this triangle is just equilateral, because what's happening is we're rotating this 2 pi I over 3 counterclockwise radians, and then 2 pi I over 3, and then 2 pi I over 3 again. And since this is a circle, we must have that these three lengths are equal to equal. That's the highlight of a proof. Okay, so now let's just calculate a side length, right? So the side length will be z times e to the 2 pi I over 3 minus z. And then using basic argument properties, which I'll let you prove, this is just modulus of z times e to the 2 pi I over 3 minus 1. Great. So modulus of z is 2014. What's the modulus of this? That's just cosine 20, negative 1/2, and then this is plus root 3 over 2i minus 1, negative 3 over 2. So modulus of negative 3 over 2 plus root 3 over 2i. What will this be? Well, if we find the square of the modulus, that'll be 9 over 4 plus 3 over 4, which is 3, so root 3. So side length will be 2014 root 3. And using the formula for the area of an equilateral triangle, we have root 3 by 4 times 2014 squared times 3. Okay, so it can be written as n root 3. So what can we do now? Let's just write this as 2014 squared over 2 squared times 3 times root 3. Reason I wrote this as 2 squared is now we can combine this as 1007 squared times 3. This is our n, right? And then we want to find it when n is divided by 1000. So if we take this modulo 1000, we get 7 squared times 3, which is congruent to 49, 147 modulo 1000. And we are done. The answer is 147.